Welcome to another segment of my videos. That is, we are looking at a new topic called circle theorem. So we want to understand the circle properties, and this is what I'll focus. So in this video, I'm going to focus on, highlighting all the properties of a circle that will help you to answer questions under circle theorem. Then later on, we are going to focus on how we can answer those, examination type of questions. So let me just highlight in my first diagram there a few concepts that you need that we are going to be using as we go on in our discussion. So for example, if this is a circle and that is my center of the circle, or I can draw a line, cutting through the center or passing through the center of a circle. So if I draw that line passing through the center of a circle, then I label that one. If that is A and that is B, the far end, and that is the center we have highlighted. So this forms up what we simply call as being the diameter. So that is the diameter. So the diameter, the full length, is what we are calling as being the diameter. But if I was to draw, a line from the center to any point on the circumference of a circle, to any point on the circumference of a circle. For example, let me call that one as being C. Then it simply means that, this distance from the center of the circle to the circumference or to the edge of a circle, that is what we simply call as being the radius R. The diameter, we can represent it by D. Now remember, the diameter is twice the radius. In other words, we mean it is twice the radius. It is actually 2r. That's what you need to remember. On the other hand, have another circle, but this time have a center O, but instead of drawing a line passing through the center, it is, touching just, the circumference of a circle. So now let's introduce you to a few ideas that you need to remember under the circle. So this line that I've drawn, touching the circle at 2 points along its circumference, the whole length of that line AB, that line AB forms up what we simply call as being a chord. So that forms up what we are calling as being a chord. Now, if you notice, there are two segments of the chord. There's the upper part going up and going below. Let me shade, this section going, to the bottom side. So the part that I've shaded is simply called as being a seg. We call that one as being a segment. Even the upper part, it is also called as being a segment. So we call it as being a segment. Now, how do you differentiate between the two segments? If you notice, the shaded part is actually small. So therefore, we call it as being a minor segment. And because the unshaded part there is big, so we call that one as being a major segment. So if you were to move along the circle, the circumference of a circle along AB on the shaded side, along the shaded side, that forms up what we simply call as being the arc length. So that's the arc length. Even if you were to move along that, we simply say that is the arc length. Yeah, so you can have the minor arc length and you can also have the major arc length. The arc length talks about along what we are simply calling as being the circle, the circumference of a circle. So that is what you need to remember. So those are simply segments. And throughout our discussion in circle theorem, we are going to be referring to these. You should be able to have, ideas of what we are talking about. So right away, we can now start with the first property of a circle. Let me say property number 1. I normally love to say there are about 8 properties that you need to know well. But of course, you are going to see as we move on. The first property is a property relating to the angles at the center and the circumference. So let me say that, angle. Can I just try to clean and write that one properly? So we can simply say, angle at the center. So the angle at the center and circumference. So the angle at the center and circumference. Now, what about the angle at the center and the circumference? Well, according to this property, it simply tells us that the angle can simply say that the angle at the center is always twice. The angle at the center is twice the angle on the remaining part of the circumference. What do I mean? Well, I'm going to illustrate it nicely so that you are able to pick it up. I'm using my glass in order to draw my circles properly so that I can actually help you to understand better. So imagine you have a circle like that, and let's say this is the center of a circle O. So according to this property, it tells us that if, for example, I do have a point I'm simply calling as being point A. Let me call this one as being point A, and I'm having another point there I'm simply calling as being point B. If I was to draw again from this, if I was to draw from this, chord AB and extend it to any point on the circumference that side, if I was to extend it, for example, I take it in that direction, then I bring it back, to that point B, subtending. Remember, they're actually coming from the same chord. That's what we mean. According to the property, it says that this angle at the center, AOB, will always be twice any angle on that remaining part of the circumference. So if that is point C, it simply means that the angle ACB will actually be X. It will be half of the angle in the middle. So that's the property that we are talking about. The angle at the center will always be twice the angle on the remaining part of the circumference. What do I mean? Well, let me try to amplify, that further so that you can actually get to understand what we mean when we say that. Well, it simply means that, again, if I have this as my center and I do have, the point A, B, then I extend, from there touching the circumference, then it comes back to the same point. If this is the center that I have, that's the point C. If this angle, for example, is 120 degrees, it simply means that what would be this angle there? Well, the angle here is twice the angle on any remaining part of the circumference. So to get this one, you say half of 120, which is 60. So that angle is equal to 60 degrees. And that's what this property simply entails. Now, I want to illustrate this property again in a different way. Notice again how this property can also be illustrated. Allow me just to flip so that you are able to see. I demonstrate what that property simply means. So according to this property again, we can also write it in this way. I can also write it in this way. Again, I have my center there. I'll call it as being center O. So I'm going to draw again. I'm going to draw something like that again. Right, I'll be using different markers so that I can just help you, to comprehend, what I'm talking about nicely there. Just to help you comprehend. So again, I'm going to say if this is A and that is B, another property, we talked about this is twice that one, but you can also talk about this angle outside. Let me write my point or inside here. This angle outside here is always twice the angle. If you were to draw another triangle in the minor segment, starting from A and B from the same chord again there, if you were to draw from the same chord again but in the opposite side, this angle outside will again be twice this angle that you have there. So very important to remember that. So if this is 2x, the angle outside, it simply means that this will be half of what is outside there. So very important that you remember again this concept. It's the same. The angle at the center is twice the angle on the remaining part of the circumference. Remember, here I said this angle is twice that one. But here now, I've actually said the angle outside there, in this case, is actually equal. In other words, we can say, the reflex angle outside is twice this angle that you have there. That's the first property. Let's move on and go to property number 2. What is this property number 2 that we want to talk about? Well, this property says that, angles in the same segment. So it's angles in the same segment. So what does this property, say? Angles in the same segment. Well, according to this property, it says that angles, we can maybe say angles in the same segment, subtended or coming from, subtended by the same arc, or if you want, you can say by the same chord, are equal. So that is what, this, second property says. So angles in the same segment subtended by the same arc or chord are equal. That's what we mean. What do I mean? Well, let me try to illustrate it again. So I'll use my cut there just to draw the circle. I'll use that to try just to draw a circle. So what do I mean when I say that? Well, let's imagine that you again, have, it could be that you have your center there. Maybe that's your center O, but you have again a chord there, which we are calling as being AB. You can actually have, it's okay even if it passes through the center there, and it comes back, to A. Then again, you extend it in this case, let me use a blue marker, from A to that side, then it comes back to the chord, to B there. So according to this property, it says the angle subtended in the same segment. So this is in the same segment because this is the major segment. These two guys are coming from the same arc or from the same chord, and they're in the same segment. So it simply means if this angle is X, it simply means that that angle is X. That is what that property, simply means. So for example, I can put it this way. If you have drawn a line like this and you have something like that, and this is A, B, C, and that is D, it simply means that if this angle here is actually 40 degrees, it simply means that this angle will also be 40 degrees. Angles in the same segment. That is the property that we are using there. Right, we can move on and look at another circle property that you need to remember. This property here, I'll write it the other way around. Let's just clean up again to create more space. So according to the third property that I want to give you, this third property states it's the angle in a semicircle. So we are looking at angles in a semicircle. So what about, so it talks about angles in a semicircle. So according to this property, it says, that should be in a semicircle. So according to this property, it says that, it states that, angle, maybe let me say an angle, maybe let me put up and simply say an angle, an angle in a semicircle is always 90 degrees. So that's what we mean. So angles in a semicircle is always 90 degrees. So what do I mean? Well, if you have a circle like this one here, and it has a center we are calling as being center O there, and you draw, a line through the center. You remember, of course, that if I have the line AB, that is representing the diameter. So if you were to draw, from that far end to the circumference of the circle, and you from that same point from A to that point to meet that, it simply means that this angle here that you have is actually a 90 degrees angles in a semicircle. This is also true even if you were to draw at any point from, as long as it is moving from A, touching any point along the circumference to where we are calling as being, B, the far end there. What happens is that this angle here, because it's also in a semicircle, half of a circle, it simply means that that is also 90 degrees. So that is what, the property talks about. But let's move on to another property, that is property number 4. That we can talk about. Now, this property number 4 that we want to talk about has to do with, a cyclic quadrilateral, a quadrilateral. So it says, maybe we can simply say opposite angles. So we are now looking at opposite angles of a cyclic quadrilateral. So opposite angles of a cyclic. Cyclic, it's like in a circle. So opposite angles of a cyclic quadrilateral. So according to this, property, it says or states that, opposite angles. So opposite angles of a cyclic quadrilateral. So opposite sides of a cyclic quadrilateral are supplementary. So they are supplementary. So what do we mean when we say supplementary? Well, I mean, they add up to 180 degrees. That's what we mean when we say they are supplementary. So opposite angles of a cyclic quadrilateral are supplementary. Well, let me show you. Let me try to illustrate it this way, so that you are able to see again this property, a very important property that you are going to be finding in the exam, a very important property there. Now, imagine you have a quadrilateral. Imagine that you have a cyclic quadrilateral. If that's still the center, we can have something that looks something like this. Can have something that looks something like this. All right. So now what we have created, let me say that this is A, this is B, this is C, and this is D. So all the 4 points are touching the circle. Then you have what we call, I love to call it an internal cyclic quadrilateral, because it is formed inside of a circle. Now, according to this property, opposite sides of an internal cyclic quadrilateral add up to 180. What do we mean? Well, imagine if this is, X, and that is Y. Let me say that is, let me say that is, okay, let me say it's W, and let me say that is Z. Well, opposite sides of this cyclic quadrilateral add up to 180, meaning if you add X plus, sorry, I say this is Y. If you add X plus Y, it should add up to 180 degrees. If you add W and Z, W plus Z, it should add up to 180 degrees, because opposite sides of an internal cyclic quadrilateral add up to 180. So you need to remember, this property, very important. Well, let me just try to illustrate that. Imagine, let me use a blue marker. Imagine that this angle here is 60 degrees, X is 60 degrees. You can find what Y is there, because you know that the two will add up to 180. So I can just take the X the other side, such that it will become now Y will be equal to 180 minus x. So meaning my y there will be equal to, I'll just say 180 minus 60 degrees, which is going to give me 120 degrees. So this one here would actually be 120 degrees, such that when you add the two, it will give you, 180. Now suppose I say W is 100 degrees. Well, if W is 100 degrees, I can know what Z is, because to find Z there, I can simply say Z will be equal to 180 W cross over there minus W. So meaning that Z will be equal to, you just say 180 minus this angle you know already, which is 100 degrees there, which will give you 80 degrees. It simply means that that guy Z is 80 degrees. When you add the opposite, it should be able to give you 180. That is what this property simply tells you about that. All right. Now, before I talk about another cyclic quadrilateral, this time an external cyclic quadrilateral, I want to talk about the fifth property, a very important property that will give you ideas on the previous one. So in this one, allow me just to clean up here my board here so that I can quickly illustrate this one. So in this case, the fifth property that we want to look at, the fifth property that we can look at is the one that talks about the angle between the tangent and the radius. So we can talk about that property. So we can talk about maybe the angle between tangent, the angle between tangent and radius. So now, what does this property talk about? Well, it simply says, the angle between the tangent, we can simply say the angle between the radius. So the angle between the radius and tangent. So the angle between the radius and tangent is 90 degrees. So that's what we know. So the angle between the radius and tangent is actually 90 degrees. What do I mean? Well, let me illustrate it for you so that you are able to, to know. So imagine you have, a complete circle. So you have a circle there. So when you have a circle, you have a center there. That should be a complete circle. So imagine you have a center there, or what we mean, you can actually draw a tangent to the circle. Remember, a tangent is just touching the side of a circle. So let me say I do have this one, and let me call it as being TU. So TU is representing what we are calling as being the tangent. So if you draw from the center to the point where a tangent is touching the circle, from the center to the point where it is touching a circle. Remember, this is what we simply called as being the radius when I just started in my preamble. So the angle between the tangent and the radius, this angle here, let me use a blue marker. This angle, all right, it's okay, even this one, this angle here is actually a 90 degrees. That's what we mean there. Even this side, remember, a straight line add up to 180 supplementary, so it simply means that even this side it is 90 degrees. This is the fifth property. Let's look at the sixth property of a circle that you need to remember. Remember, these properties are important to answer any questions under circle theorem. So now I can look at what I'm calling as being an external cyclic quadrilateral. So I can look at an external cyclic quadrilateral. In other words, we can simply say, tangents, to circle. So we can say tangent to circle, from the same, point. So tangent to the circle from the same point, right? So we can simply maybe give you some concept. We can say, the two tangents, maybe I can talk about the two tangents. The two tangents, to a circle, the two tangents to a circle, from a given from a given point, are always equal in length. Yeah, they are going to be equal in length, to where they touch the circle. So that is what you need to remember. Yeah, so how can I illustrate this so that you get the concept? Well, this is a very simple one. Let's say that you have a circle. My space is small here, but I'll try to see if I can demonstrate it nicely. Imagine you have a circle there, then you have a point somewhere. Let's say that you have a point, an external point here outside there. Let's call this point as being point T. Then we can draw, from this point we can draw a tangent to touch this circle from that external point, there. So from that external point there, so we can draw like that, and I can also do it the same this side from that point to touch the circle. Remember, these are representing the tangent. So to touch the circle somewhere at some point, to meet at point T there. So let me say where it is meeting here, meeting the tangent, that is A, then somewhere here, let me call it B. So AT is a tangent and BT is also a tangent. Now imagine if you have a center we are calling as being O there, you have somewhere there a center. Let's try just to imagine that you have a center at that point. If you draw from that tangent to meet the center of a circle, I'm calling as being O there. And of course, I also do the same, from where it is meeting there to from the center to where it is meeting, the tangent is touching the circle. It simply, remember the angle between the tangent and the radius, so it simply means this is 90 and also that is 90. Now, according to this property, you need to remember that if you have this, according to me, I love to call this property as being, this is an external. I love to call it as being an external, cyclic quadrilateral. That's what I love to call it, because it is in an external. Again, opposite sides are supplementary. So this angle plus 90 is 180. It simply means this angle at this center should be add up to 180 with that one. So this and that will add up to 180. So if you say x plus 1, that should be able to give you 180 degrees. Don't worry, I'm going to show you when it comes to practice questions. This is what we call tangents to circle from the same point. Let's try to look at the seventh property that we can talk about under circle theorem. Very important properties. These properties are supposed to be part of your toolbox that you have. So make sure that you put them in your head. So let's look at the seventh property that we can talk about. Well, the seventh property is a property that talks about the relationship between the tangent and the chord. So we can simply say, let me call it as being alternative. So you can call it as being alternative, segment, theorem. That's what we can call it, alternative segment theorem. What does this theorem say? Well, it states that the angle between a tangent, so the angle between a tangent and a chord, so the angle between a tangent and the chord is equal, to the angle subtended, let me say subtended, by chord in the alternative. That's the key word, in the alternative segment. Very important concept there. Let me try to illustrate what I mean that. In other words, the angle between the tangent and the chord equals to the angle in the alternative segment. That's what I mean. So I'll try to demonstrate that this way. Let me try to see if I can use maybe 2 so that I try to demonstrate that. So imagine we have a tangent. Let me again draw a tangent here. I have a tangent to a circle. I have a tangent to a circle, and it is meeting the circle at a point B. Then I'll use a blue marker for my chord, and imagine I do have what I'm calling as being, a chord, and I'll call that one as being, the chord is ABC. That's the chord there. Of course, you can have your center of your circle. So now I can draw from this same chord, I can draw, a triangle to go and meet, the circumference of a circle to that point like that. So what do I mean according to this property? Well, the angle, let me call this one ABC, let's call this one as being D. Well, we mean the angle between this tangent, this is a tangent that we have there, this is a tangent, and this chord I'm looking at here, if this angle here, if this angle, for example, is maybe we say, 60 degrees, it simply means that the other side, this angle also here is actually 60 degrees. So that's the angle between the tangent and the chord equals to the angle in the alternative segment. The same is true if you say that this angle here is actually 48 degrees, the angle between this tangent and the chord now BD will be equal to this angle here. It will also be 48 degrees. That's what you need to remember. So that's what we call the alternative segment. All right. So in my next video, I'm going to show you how you can use these 7 properties to do, some calculation. So we'll see you in my next video as I look at, calculating examination type of question on circle theorem. Thank you for your attention. See you in my next video.